Good morning to one and all. Now we are going to discuss about the unit 3 topic laser. Last class continuation lecture 5 discuss about the topic homo junction diode laser and heterojunction diode laser. This was one of the semiconducting devices and semiconducting material are used. Homo meaning single compound doped this pure form of semiconducting materials. Heterojunction meaning more than two or more compound mixing this semiconducting materials. And basic fundamental for used PN junction diode. So diode, how to consider the diode material. PN junction diode, there are two terminal consider, one terminal anode reaction and another terminal for connected to the cathode. These are light sources for emitted, the forward and reverse bias or power supply are connected. This is a recombination of electrons and holes moving timing, emission of light source. This basic principle occur in the PN junction diode. These are P type. These are N type, P region, N region, majority holes, minority electrons, N type majority electrons, minority holes. The both for mixing PN junction diode, this for in between center layer, these are negative ions, these are positive ions. The holes represents for this white color sphere, this yellow color sphere for free electrons for represent. Keep this electrons moving from N to P, P to N. It's a recombination of electrons and holes, N region to P region, P region to N region. Okay, this is center in between gap, the recombination of electrons and hole timing, emission of light beams are produced. Okay, this is one of the diode laser. This laser beams are producing. This concept applied this semiconductor laser. There are two types, homo and heterojunction diode laser. Homo junction diode laser, this major three characteristics are given. First one, active medium. This active medium consider PN junction diode, P region gallium and N region arsenide. These junctions of the material are doped. This is a pumping method. Pumping actions are occur. These are four methods. One of the method, direct conversion method applied. This electrical energy is conversion to the light energy. And third one, wavelength of the output. This homo junction output wavelength 8000 Armstrong to 8600 Armstrong. And band gap of the value 1.44 electron volt. Using photon energy equal to h nu basic formula use. Okay, you go to find out the band gap value. And different types of characteristics are given, and then principles of homo junction diode laser, gallium arsenide laser. Okay, this gallium acting in this P region, this are upper electrode material, this is lower electrode material N region, that is arsenic material for coated. This is both for mixing PN junction diode, that is gallium arsenide for mixing active medium. This active center for recombination of electrons and holes moving. This is active center. This is one of the type of homo junction semiconductor diode laser. This is a pumping process, direct pumping. This upper electrode is connection to the power supply forward biasing, and the negative sign connection to the lower electrode negative region. This are electrical energy is conversion to the light energy producing this for PN junction diode polished surface using PN junction diode, that is a resonant cavity. This is both side for polished surface material, the polished surface producing this laser beam. This laser beam output 1 milliwatt. This nature of the output for pulsed and continuous waveform. This band gap values are calculated 1.44 electron volt. This output laser beam for producing 8400 Armstrong to 8600 Armstrong. Okay, this overall, this homo junction diode laser, this stimulated emission process occur timing only laser beams are producing. For electrons, conduction band to the valence band to the conduction band. This electrons and holes moving. The recombination of electrons and holes moving timing, laser beams are emitted. Okay, this emission of light beams for laser source. With respect to the forbidden energy gap, okay, where laser beams are producing. You have to consider this energy level diagram. This is P-type region, N-type region, conduction band energy level. This is upper energy level conduction band. This is lower energy valence band energy level. This is majority valence band energy level. Majority for holes, minority electrons. Conduction band majority for N-type semiconductor. Majority for electrons, minority holes. The Fermi energy in between the gap, conduction band to valence band energy level. The forbidden energy gap in between gap. Okay, this conduction band electrons moving from valence band holes moving from conduction band. This electrons and holes for moving timing, laser beams are emitted. Okay, this conduction band electrons moving through this valence band. This valence band electrons and holes moving from conduction band. These are partially conductions. These are semiconducting devices. Okay, this electrons moving timing, laser beams are emitted equal to h nu dash. Okay, this recombination of electrons and holes timing, laser beams are producing. This in between gap, this region for active region. Okay, this pumping actions are producing. Okay, this N2 is greater than N1. This population inversion is achieved. This is stimulated emission process, the laser beams are producing. And finally, we have to calculate this homo junction diode laser wavelength, band gap of gallium arsenide 1.44 electron volt, forbidden energy gap Eg equal to h nu for h Planck's constant, nu for frequency of radiation, nu consider C by lambda, okay, and hc divided by lambda. This lambda you can find out lambda equal to hc by Eg. Okay, we go to substitute this constant value h 6.625 in 10 power minus 34, c velocity of light 3 into 10 power plus 8 divided by forbidden energy gap 1.44 in 1 electron volt, 1 charge of 1 electron 1.6 in 10 power minus 19 coulomb. We go to substitute this value, simplify this value, wavelength of this laser beam, homo junction diode laser beam 8626 Armstrong. This wavelength nearby infrared region. And advantages of homo junction diode laser, it is easy manufacturing method. This devices for low cost. Okay, disadvantages of the material, this is a low power output. The output wave is a pulsed and continuous waveform. This is a large divergence of the beam. They have high threshold current density. And next, heterojunction diode laser. Hetero meaning two or more compound mixing this pure form of semiconducting material. This hetero gallium aluminum arsenide material. We have to consider this material. These are major three characteristics are given. Active medium PN junction diode. These are various layers are given. Pumping method, direct conversion method are used, and wavelength of the output value 8000 Armstrong, band gap value 1.55 electron volt. Characteristics of the laser, heterojunction diode laser. Characteristics, which type of laser? Heterojunction semiconductor laser, active medium PN junction diode material using gallium aluminum arsenide PN junction diode laser used. Active center, this in between gap recombination of electrons and holes are moving. Pumping process, direct pumping method, electrical energy is conversion to the light energy. The center medium, active medium center for both side optical resonator consider, both side for polished optical mirror using. Okay, the polished surface partially containing mirror only. We go to using this laser source. This is a power output 10 milliwatt. Nature of the output continuous waveform. Wavelength of the output 8000 Armstrong and band gap value 1.55 electron volt. So construction of the material, heterojunction diode laser. This are upper layer, upper electrode consider gallium arsenide P region P type material and gallium arsenide N type material consider. This is a lower electrode. The upper electrode, lower electrode, anode and cathode is connected to the forward biasing. And then second layer, third layer, gallium aluminum arsenide p-type region, gallium arsenide p-type region, and the fourth and fifth layer, gallium aluminum arsenide doped this material n-type and gallium arsenide n-type region. This 3 and 4 in between gap, this polished surface are analyzed. The polished surface only laser beams are producing. This for construction and working principle. Okay, this each layer for explain it. Gallium arsenide and gallium aluminum arsenide. Okay, this p-type n-type in between gap laser beams are producing. The charge carriers are continuously, these are positive p side, positive region. Okay, holes are induced in this side, charge carriers, electrons are induced. Both charge carriers are injected in this layer p gallium arsenide layer and n gallium aluminum arsenide layer. This third and fourth layer in between gap, recombination of electrons and holes moving, population inversion is achieved, pumping actions are occurred, N2 is greater than N1 timing, for stimulated emission process, these laser beams are producing. These are energy level diagrams are given. These are holes and then electrons, valence band, conduction band. These are recombinations of electrons and holes moving timing, emission of light beam. These are Fabry energy gap level Eg1, this is Fabry energy level Eg2. This heterojunction diode laser, this wavelengths are analyzed. Lambda equal to Hc by Eg, H value constant, C constant, Eg for 1.55 into 1 electron volt 1.6 10 power minus 19. You have to simplify this value, wavelength of the emitted laser beams value 8014 Armstrong, that is nearby infrared region. These advantages of the heterojunction diode laser, this power output is very high, the manufacturing method is very tough, this is high directionally high coherence beam, this is low threshold current density. In compare that homojunction diode laser, these are LED, LCD and then organic LED devices purposes are used, and switching devices using heterojunction diode lasers are used. And disadvantages are higher than the homojunction diode laser, cost is very high, so practically the manufacturing for very tough. And what are the applications of semiconductor diode laser? Tablet model and virtual reality, and then 3D, 5D, these images are considered, and then smart home, IoT, and then automotive, drones, and then gaming and TVS, and then PCS, personal computer, notebooks and smartphones. And then this is a black chat of laser diodes application, optical pumping, healthcare field, optical sensing line, material processing field, defense field, medical field, data storage, communication field, display illumination field. And your circuit designing, your electronic circuit lab and ECEEE lab and power semiconductor devices are using. More than chips are analyzed, 2-terminal devices, 3-terminal devices, the chip IC fabrications, the chips are calculated, and then 2-terminal devices for PN diode and then Schottky diode, and 3-terminal devices for power MOSFET, JFET and IGBT and BJT, thyristor. This for charge carriers devices are producing using semiconducting materials. Okay, these are 2-terminal devices, minority charge carriers, 3-terminal devices output minority charge carriers and majority charge carriers are given. This is single electron transistor using, and then field effect transistor, okay, JFET, MOSFET are analyzed. This is a different type of model where semiconducting material are used. And differentiate homo and heterojunction semiconductor diode laser. This is a major points only given. Point number 1, homojunction diode laser is made by a single crystalline material. This is made up of different crystalline material. This power output is low, this power output is high, pulsed output and continuous waveform also, and heterojunction only continuous waveform. So high threshold current density homo, hetero low threshold current density. This cost is less, this cost is more, lifetime is less, lifetime is more. The examples of homojunction diode laser, gallium arsenide and indium phosphorus. And this example, gallium arsenide doped this gallium aluminum arsenide, indium phosphorus this doped in indium aluminum phosphorus. and differentiate direct and indirect band gap of a semiconductors. Direct band gap of a semiconductor, during this recombination of electrons and holes timing, light beams are emitted. This photon light beams is called laser beam. For example, gallium arsenide. This is a fabrication of light emitting diodes and laser devices. Indirect band gap semiconductors, during the recombination of electron and hole timing, heat energy is released. Okay, heat energy released, this compound in germanium and silicon. It's a pure form of intrinsic semiconducting material, indirect band gap of a semiconducting material used. How is a light emitting diode different from a semiconductor laser? Light emitting diode and laser. It requires low current density light emitting diode. Laser for high current density. The junctions of diode need not be polished. This laser diode for highly polished, this both side only laser beams are producing. So minority charge carriers injected in this material. This was more than recombination of electrons and holes, moving timing. The simulated emission process occur timing, laser beams are emitted. Power output is low, power output is high, intensity is less, intensity is very high. Okay. Overall, this lecture 5, learning outcomes, principle of semiconductor laser, difference between homo and heterojunction diode laser, and homo and heterojunction working and the principal advantages and disadvantages are analyzed, differentiate direct and indirect band gap of a semiconductor, and how is a light emitting diode different from a semiconductor laser. Thank you all. Thank you one and all.